All right, section 11.4, three-dimensional figures. Our objective today is going to be classify solids. Basically, that means we're basically going to name them, give them a name. We're going to describe the cross-section. What shape is that cross-section? And we'll talk about what that means, cross-section. And sketch, so we're going to be drawing some sketching, and describe solids of revolution. That's when I take a solid, if I take a shape and spin it, what kind of solid does it make? Okay, so first we need to talk about the idea of a solid. A solid is a three-dimensional shape, meaning it's difficult to draw it on a piece of paper because a piece of paper is only two-dimensional. So we need some tricks to draw it in 3 dimensions, and that's normally figured out in art class. But again, your templates, really good help for there if you're sketching, when you're sketching these pictures. Okay, so a polyhedron is a type of solid. What we mean by solid, again, is those 3-dimensional shapes. And it's created or bounded by, bounded by polygons. And if you remember, a polygon, triangle, quadrilateral, pentagon are all polygons. Polygons, again, are made up of straight lines. Okay. So our polygon is made up out of those straight line sides. So over here, again, over there, over here to the right, right here, I have a polygon. Okay. The faces of these polygons, the faces are made up out of those polygon sides. So the faces are made up of those polygon sides. Okay, so we have a face right here, this polygon right there, which is a trapezoid, is a face. This polygon here, which is a rectangle, is a face. Okay, so this actually has, if we count the faces, it's got the one in front, it's got the one in back, and then 1, 2, 3, 4 around the outside. So this one actually has 6. This picture right here has 6 faces. Okay. Right? The edges are the line segments. An edge is just a line segment. Line segment where the faces meet. The line segment we'll go at the intersection of the faces. So the line segment created again. So then here's an edge right here. Here's an edge right there. There's one here. So anywhere here, anywhere where the faces meet and they create that line segment, we call an edge. And our vertices, our vertex is the point. It's a point where the edges intersect. Okay, right. The plural of polyhedron is polyhedra. So we don't say polyhedrons. We say we have a polyhedron or plural polyhedra. Okay, some examples of things that are polyhedra and are not. If you notice over here, our polyhedron here is a prism. Again, all of the sides here are made out of these rectangles. This pyramid down here is a polyhedron. The base is made out of a square. The sides are made out of, we call those lateral sides. The sides are made out of triangles. But if you notice here, these are not polyhedra. They're curvy. A cylinder is not a polyhedron because its base is not a polygon. So basically, these not a polyhedron, base is not a polygon. Or it has no base at all here, like our sphere has no base at all. Okay. So a prism here, our prism right here, is made up of two bases So you have two bases. Okay, so our two base, our one base would be this one up top. Other base would be this one on the bottom. And then it has rectangles for all the other sides. Okay, so it has those two bases and then rectangles on the sides. Two bases and then rectangle sides. Okay, that's a prism. The base, in this case, this base is a rectangle, so we call it a rectangular prism. We name it based on its base. If the base was a triangle, it'd be a triangular prism. Okay, and then here for a pyramid, it just has, our pyramid here has one base, but again, then it has the triangular sides. Okay, so this here again we name it based on the base. So this thing we would call, if that was a square, all sides are the same and 90-degree angles, we would call that a square pyramid. We name it by its base. This one, the base obviously looks rectangular, so we'd call it a rectangular. Ooh, that's not how you spell rectangular. Rectangular prism. So let's name a few. Tell whether each solid is a polyhedron. If it is, name the polyhedron. Okay. So this first one here, if we notice the base, I can see the base right here is this right here. There's the base, 1, 2, 3, 4, 5, five-sided base. The sides here are these triangles. So to me, that is a polyhedron. Because, oh, I'm having a hard time spelling today, guys. Polyhedron. Because all of its sides are polygons. And this base is a pentagon. 1, 2, 3, 4, 5. So it's a pentagon. Pentagonal. Now, is this a prism or a pyramid? Well, it comes together as a point up here, so it'd be a pentagonal prism. Oh, no, no, no. Wrong word. Pyramid, because it comes to a point. Pyramid. It doesn't have two bases. It only has the one base down here. This one base down here coming up to a point. The sides are triangles. It makes it a pentagonal pyramid. Okay. Now this next one, let's look at the shape here. It looks like its base here is a circle. Since it's a circle there, I can tell it is not a polyhedron. I could not draw it with a straight edge. It's not a polyhedron. So it says if it is, name the polyhedron. So we don't have to name this, but I would actually call it, it's a sphere. You don't have to do that, but it's half a sphere, so we call it a hemisphere. Or a semisphere, depending on. Either one means the same thing. All right, now this next one, if we see here, okay, so now we have to figure out where's the base. The two bases, one needs to be on top of the other, so my base actually, I think, is this guy right here, because there's another one back here, and these sides are rectangles. So that would be a prism, so that makes it a polyhedron. And it makes it a prism, but what kind of prism? The base here, that guy right there, kind of hard to tell since I scribbled all over it, has, let's see, 1, 2, 3, 4, 5, 6 sides, so that's a hexagonal prism, because its base is a hexagon. Base isn't always on the bottom. The base in a prism, again, is the two pieces that are one above the other. We say in parallel planes, so there's our two bases, there's the one. There's the other. Okay. In parallel planes, one above the other, and connected with the rectangles. So there's our rectangles. Our rectangles are all the other sides. Okay. All right, next. Okay, cross section. I always like to think of a cross section. If I took a piece of plastic and I sliced it, what shape would it make? What 2D shape? What 2D polygon is created by slicing the solid? Okay, so here we have, this is a square. These are all pictures of a square prism, which we often call a cube. A square prism is often called a cube. And here's different ways of slicing it. I could slice it straight horizontally, straight through the middle right here. And if you notice, that shape that's created there in the middle, again, we kind of have to visualize it, is a square. Okay, I could come through and here, like in this one, cut it at a diagonal. Here, if I cut it at that diagonal, okay, if you notice in there, we create a rectangle. We've got a rectangle right here. I could also cut it at an itty-bitty diagonal over here in the corner and actually make a cross section that's a triangle. Okay, so these are all different ways of cutting a polyhedra to make a 2D shape. Okay, so let's see if we can't visualize what these look like. So describe the shape formed by the intersection of the plane and the solid. So here I have my plane, there's my plane right there, slicing through this solid. And I want to figure out what shape is made by the intersection. If you notice, this guy right here, from here, is created, that 2D shape. And that 2D shape, it looks like part of a circle. And it's actually a semicircle is created in there. Okay. All right, now let's look at this next one. Again, we have our plane, this plane right here, cutting through that shape. And what figure is at that intersection, meaning what points are on both the plane and my solid. It's that one right there. It's got 1, 2, 3, 4, 5. So that 2D shape is a pentagon. Okay. All right. Next, a solid of revolution. Okay, a solid of revolution. If I take a two-dimensional shape, like here I have my rectangle, my two-dimensional rectangle, and if I rotate it, spin it around this axis, so this is the axis I'm spinning it on. So imagine I'm holding this line right here, and I'm spinning this figure. Okay, as you can see here in this next picture, I'm spinning it around, spinning it around. What kind of shape does it make? That's what's called a solid of revolution. A solid of revolution is a 3D shape, or I guess we'll use the book term, a 3D figure formed by rotating a 2D shape around an axis. And that axis we call the axis of revolution. Because depending on which way I rotate it, like if I wasn't rotating this thing this way, if I was rotating it this way instead, okay, it would be actually the same figure, I think. It would just be a shorter, fatter one. It would create for me a cylinder that looks more, that looks like, oh geez. A shorter and fatter one. Let me do it by hand, that's faster. It would create for me a shorter and fatter cylinder, okay, if it was rotated around the other direction. So the solid of revolution does depend on what axis you're rotating it on. Now, if I was even rotating it on a diagonal, it would create a very different figure, okay? Okay, so there's our solids of revolution. So these, again, take a little bit of visualization, trying to figure out, okay, what does the shape look like, okay? So here, sketch the solid produced by rotating the figure around the given axis, then identify and describe the solid. So we're taking this triangle right here, this red triangle, and we're spinning it around. So it's going to spin this all the way around. You see there, it looks like I'm going to have a cone, because I would take this triangle and it's going to spin it around, so it'll be in, that's going to sweep out. We do dotted lines in the back, and it's going to create a cone with a radius here of 4 and a height here of 6. So it's going to create a cone. Okay, like an ice cream cone, because it's going to spin it around. Then identify and describe this solid. It's solid. It's going to create a cone. Let's describe it. With a radius, a base radius of 4, and height of 6. Okay, now let's look at this next one. So here I have a semicircle, and we're going to rotate it around. So this is going to spin all the way around. So it's going to create something like that, and it's going to be a solid. So that's going to create a sphere. Now, how do you draw a sphere? Circle, a circle. Use a compass. I don't have one on this. And then go like this, and then dotted in the background. Okay, so it's going to create a sphere there with a radius. So it's going to create a sphere with a radius of, looks like they're 5. A sphere with a radius of 5. Okay, all right, there you go.